Neat. All right, I have my homework. We should be very professional about this. So hi, I'm Dael. We didn't say that at any point at the beginning. All right, I'm Dael.
I'm Graham.
We're doing a video.
And it's part 4, and I will put links in the video, and I would suggest you don't start here.
Yeah.
I'll put this at the front.
Yeah, great. They'll be like, ooh, what is this?
What on earth is that?
What is this finished, this magnificent?
It's only in keeping with our first video where...
It's great.
Righto. We're back.
We're back, baby!
Different clothes and everything. Even had a shower. Yeah, cool. But I don't have the socks.
That's true. My socks match. Literally, they're both X-Men.
Wow. It was meant to be.
Perfect.
So, okay, I left you with some homework.
You did.
And I think maybe we'll start with you explaining what you think, and then I can work around that rather than me blurting it all out.
All right. So I've done the homework kind of twice in 2 different formats.
Right.
Because I found one place where I get it, but I'm not sure whether I get it. You know what I mean? So we were talking about, the nouns and all the things. We were talking about the whatevers. Where's my... I need to find my file. Give me a second. All right. So I did one where it's all the objects, I think.
Right.
But couched in terms of this type of thing has these.
Mm.
And then I did one that is these objects are a type of this other object. So I've kind of just done it twice.
That's all right.
Okay, great. So in terms of classes is what you called them. But I don't know whether I've gotten this quite right. But I've got classes as objects that have these other objects which have these other objects.
Right, well, rather than unpacking it like that, why don't we start... doesn't have to be exhaustive, but just start indicating on there this begin, and we'll see how far we need to go, because I just want to see where your mind is at.
All right. So
now, if you want to have something that you consider a class, the standard way of representing a class is you draw a rectangle, and then you write the name of the class on the top, and then draw a line underneath it, and then you put all of the properties, like name or whatever, those attributes, and you draw a line, and then you put all the methods.
What? Oh no, okay.
It's all right, we'll be able to get there.
Right,
we'll be able to get there. All right, you start, we'll see where your head's at.
I'll format it the way I've formatted it, and then you can show me a corrected
well, this is it. It's
method.
all
okay,
translation.
That'll be good. Okay, great. I like that.
And remember, we have a sticky note here that we don't go above.
We don't go above it. So this should be about it. Okay, great. So we talked about world.
Yep.
And then I had within that world scenes.
Yeah.
And for me, those scenes have characters.
Yeah.
I can already hear that it's okay.
No.
Right.
It's so far it's fine.
They have locations.
Mm-hmm.
Beep, 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 beep. They have. Well, I've listed this as dialogue prompts. And they have response menus. But then, within those, okay, ha. All right, I get to do this time.
Ooh. I didn't realise how many times I go, ooh, until I watch myself back on the video.
It's very fancy. You would be excused for oohing and eyeing. So then I have for each of these things. I don't know why I've done them in the order I have done them here. But,
that doesn't matter.
But I have. So then dialogue prompts, which is going to be DP because it's quicker to write, have display text. Because that's a thing. Response menus.
Is that a verb display or is it a noun display?
Noun display. So as in, it is text that is displayed.
Okay. So I'd probably call that...
I'm going to put a hyphen in it to make it a noun.
And,
there you go.
And one of the comments, thank you, I can't remember who made the comment, I remember the comment though. It's hyphenated. Top down, hyphenated, 3 words.
3 words. Top down.
Functional.
Functional. Decompositional. Yes.
Not compositional, composition.
Well, I suppose that makes sense because it's a noun. Okay. The response menus, which I called... Oh, no, I did call them response menus. Great. Have also display text with a hyphen. Text that is displayed. They have multiple options. Clickable. There's a
Selectable.
Yeah.
Because we
That's true. We don't know whether
it's not going to be. Well, ultimately they'll be clicked, but they'll be selectable.
Right. And they also have affinity point change values. I'm just going to stop at affinity points. You get it. All right.
We're going to have to roll this back up at some stage.
Yeah, we are. Look, it's fine. Everything's fine. Okay. Then we also get... I'm going to do this backwards. So just know that this is characters, but I'm not writing the heading yet because I'm doing it
upward.
Yeah. Okay. So characters have... okay, wait. They have a dead true false label because they can be alive or they can be dead. They have the wind. They have an imposter true false label. They have affinity points.
And that's POINTS, not PIONTS.
Yeah.
Another call back to video number 2.
Yeah, the people who've been watching, they get it. Affinity points, they have images, eventually, and they have a name. And then locations also have images and also have a name, but don't really do anything mechanically. That's what I got.
Now, that was pure paranoia on your part, because there's no real problem with what is going up there.
Hey!
All right, so now we've got a sense of, all I'm just saying is there's a standard way I use, again, there are people who don't like it anymore, I use Unified Modelling Language, UML, which is a way of drawing. There are different types in UML. You can have a class diagram where you just have all your classes, and so you can set them out, and then you've got sequence diagrams where it shows this is how it goes, when this happens, that, this shows interaction between objects. And I use a number of ways to clarify in my own head. So I will now I've been, like I said, till 2:30 this morning because I was stupid and thought about it before going to bed. Thinking about this stuff. So what we're now in the process of, we've done a bit of describing, we have some background that I think just knowing that there is binary, that these things and those sorts of things, having that basic understanding of how those things work, I think helps. Mm-hmm. So now we've done that, Now we're beginning to move on the basis of what we know. I can call on those things when we need to. So what we need to start looking at now are the topology of the program, that is your classes and so forth. But even before that, we need to start to understand our algorithm. Mm-hmm. So you're familiar with algorithms as a thing?
I think I am, but also I'm just coming at it from a background of vaguely understanding the YouTube algorithm. You know,
given that is probably where our target audience will be. If you already know about this, you might be watching it too. Actually, I've been surprised at how many people that are programming people have said, that they've liked the noun versus verb ways and things like that. So that's been nice for me to see. But anyway, and I haven't been viciously attacked by anyone so far, I don't think. So here we go. Yeah. Still time. So, how would you describe an algorithm? What do you understand an algorithm to be?
I understand an algorithm to be just a sort of a bunch of programming that lets the bot run itself. So if that makes sense. I don't know whether that's a broad enough thing, but like in terms of the YouTube algorithm, it's like, here's a computer, it scans for these things, and if this thing is happening, then it will do this thing. You know, it's like just a sequence or a method of scanning through the program.
Yep, which is that's near enough.
Hey.
And then for myself, I go from, if I'm starting off something really from ground zero, and it's something that's going to be a bigger system. If you get it wrong, like even now, this is now not going to be a big thing, mm-hmm. and it may never become a big thing, mm-hmm. In terms of a large program, because you might choose to go across. Well, these people have been talking about RenPy and Godot and things that I didn't know about, and it's has been suggested that we move across to those platforms. But I'll stick to my guns and say that for the purposes of what we're trying to do, if we start down here and get something that we understand, mm-hmm. I honestly believe that when you roll over into those things, you'll realise, so this part of RenPy is actually implementing this.
Doing that.
And means I don't have to write it, but I have an idea of what it is and how it functions.
Right.
And it broadly so this is to me a good way into the language. And of course, once you get to a certain level, you go, oh man, I could spend 3 weeks writing that, or I could just, and not hash include, as some people are, yes, C++ background, from such and such import, or
this is a reference import. That I'm sure a lot of you are understanding.
In C++, if you want to import a pre-compiled library, a pre-written library, not compiled, pre-written library.
You mentioned this towards the end of the last video.
Yeah, and in Python you just go hash include.
Right.
And then someone wrote a comment going, and in Python you hash what? And then someone else underneath went, I think he's got some sort of C-like background. Yeah. So I cut my teeth in C++.
Okay.
And in C++, if you want to do that, you go hash include. But in Python, if you want to do that, you go import such and such, or from this import that. So yes, it was stream of consciousness.
But either way, you can bring it in.
So what we want to do is, if you start by just doing that, mm-hmm. you don't know what you're doing, and then when it doesn't work, you don't know how to even start to fix it.
Right.
So if we write enough of it ourselves, and we think about it in terms of, if we decided, hey, what the heck, we're not even going to go near Godot or RenPy or whatever, how might we do this that we could do it?
Right.
And I think from a programmatic point of view, always start with the assumption that it might grow. Mm-hmm. And I had this battle 20 years ago when I started at the uni. Mm-hmm. I was asked, there was a particular problem, there was some I/O, they wanted to read some temperature sensors and switch some switches. And they bought some hardware, and it came with some example software, and no one could understand how to get them to work. And I wasn't employed as a programmer. I was employed to build gear and maintain stuff. But in my interview, I said, oh yeah, and I program. And so the boss came up and said, didn't you say that you could program? And I went, yeah. And he said, we've got this problem. Can you have a look at it? And I went, ooh.
Good at your puzzle.
And over the next 12 years, what started with that was I wrote something to wrap around it and get that to work. And then they went, hang on, we've got someone that wants to fill up a cell, like pull all the air out of a glass tube. And when it gets to a certain vacuum, we want to then bring in some gas from one of 4 inlets. And then we want it to fill up and overfill and then pull back and very accurately get to a certain pressure. And then we want to measure that. So he's at the moment sitting there manually with switches doing this. Could you write something? And I wrote a program that I called automated sampling that just did that. But when I did it, I said, let's do this in a way that could be useful. Because all they're saying is, we want to solve this little problem. Mm. But I thought that little problem may become a bigger problem. So let's do it clean and just do it right. Mm. So I did it right. And then they said, can you do this automated? So I wrote automated sampling. And they went, actually, he's then having to sit there when that's done and click a button to collect a spectrum of that. Can you get it to do the button click as well? So then I worked out how to get the spectrometer to collect and added that. So automated sampling now did that. And then they said, we want to put one of these instruments up in the CSIRO in Brisbane, Cast Metals Division, and they're doing measurements of gases coming off aluminium smelting, and they're looking at these different cover gases to stop the metal from interacting with oxygen, and they're looking at the ones that they were using, HF6, is very, very toxic and bad for the environment. So they were looking at this, I can't even remember what it was, a different cover gas. Mm-hmm. And they wanted to see how well it was working. So they wanted this thing to be able to run...
It's the Post-it note. I thought it was a bug.
I don't even know where it goes.
Okay, alright. It tells you how good Post-it notes are. Yeah. This isn't even off-brand. This is actual. I got so scared. I thought that was a bug. Alright, carry on. Ooh, I'm fine. Everything's fine.
Anyway, so moving right along, I hope you haven't had a serious... We're definitely happy that that's the height.
I think so. Put your hand there.
Yeah, that's like I said. That's
yep.
There we go. I wrote. They said, "Can you have it so that we can actually see it collects a spectrum, and then real time puts an approximate retrieval of the various gases that it's being measured?" And I went, "Yeah." So I added that, and so automated sampling now did that, and then did a least squares fit of the of the spectrum, and then drew some. Now they had to be post-analysed because the least squares wasn't the best way of doing it, but it meant that they had a real-time display, and the people, and then someone down in Victoria heard about us, and they said, "Hey, look, we want to run this whole sampling program with multiple chambers that are automated to open and close and are fully remotely controlled, and we want to have it so that the numbers that are coming in are actually right, and we want to have it so the thing runs 24 hours a day, 7 days a week."
You designed it clean.
And so then I spent months writing it and went down to Victoria and we set that up. And then eventually 10 years later, I called the program OooftiPoofe, because we called our instruments Oofties, because it's one of our Fourier transform instruments.
Of course.
And so since we had Oofties, I wrote an OooftiPoofe. because it was a personalised object-oriented front end. So OooftiPoofe was nice. And then my boss came back from an international conference and said, I am never going to another international conference again and talking about OooftiPoofe. We're going to change the name.
Perfect.
And it ended up, without going into the reasons, it ended up being called Oscar. Mm-hmm. And Oscar is still running our high-resolution instrument in our old lab, and will for another year at least. And I'm in the process of writing again the program in a cut-down version in Python rather than in Visual Basic, which I hated, but I had to do it. You do what you have to do. But so that program got us to a point where we had instruments running in Germany, New Zealand, China.
Oh my gosh.
We had ones in Darwin and another one in Victoria, and we had ones on a scientific research station.
You know what else this shows? Is that like any of these places would have people who could have written something from scratch, I assume. I assume there are people who can program. But that like there is that culture of like, if you can just get it from somewhere else, like.
Well, I think, and actually, we're just chewing the fat. I work with scientists, and I came from an industry where my job was never to run the thing. My job was to build the things that other people ran. Mm-hmm. So I would be on a big lathe or a mill or something, and I'd be machining up gears, or I'd be machining shafts or whatever. And I got a drawing, and they said, make this. And I would have to make sure that it was all right and correct tolerances and so forth. And then went off, and someone else would put that machine together, and someone else would use it. It was never me. So I've always been, I guess you gravitate to where you fit. I ended up there, but it means that my whole cultural upbringing was care about the bit.
Right.
My job wasn't to worry about whether the grader worked or the gearbox ran or whatever. Mine was to make sure that the part that I produced was correct to the drawing, and if they put it in, it didn't work, but I was right to the drawing, then I was right.
Right.
And engineers had to worry about gear ratios and other stuff. So the scientists, on the other hand, they want results. And so they are always looking for the fastest way to get the numbers. So they go, hey, look, if we get some sticky tape and we drill some things and put some wood screws into this thing, it'll do. And so and it means that in 3 days we've got this thing that'll kind of just do what we need now. Because they want the numbers, because it's all about publishing a paper. It's about understanding and getting the numbers in, to understand it. So it's a means to an end for them. Whereas when I was approached, it's an end in itself. And I, for over a decade, said that I would never actually use or make sure that the instruments ran properly. I would write the software to their specification, and I was so overwhelmed with like 60% of my job was programming, and 70% of my job was everything else. So so I just didn't want to even open myself up. My boss didn't understand that I was actually trying to just draw a line.
Right.
But then that instrument, our OooftiPoofes, if you go onto the internet and you look up the Spectronus spectrometer from Ecotech, a company in Melbourne that they're international, that is our instrument that we designed in-house. And initially when you bought a Spectronus, you got my software. Now they rewrote it and ported it out of EB6 into .NET, which was a good thing. But a lot of that code is my code just put through a converter. So even now when you buy a Spectronus for $250,000 or something like that, you're getting a lot of my code that's been pushed through, and a lot of the design underneath. Now, if I had started off by saying, all I need to do is, they just want me to switch these switches, then I would have run out of puff. But because I started thinking, well, they probably want to switch other switches. And there'll be another time when they want to use these things for something else. Let's do it right. And I did. And then when they said that, and then I went, okay, there's got to be another time. And I designed the program so that you could run different sequencing cycles, and there were parameters in there so we could adapt it. We could grow the number of channels of switches, so you could run. We ran systems with 12 chambers that were all operating, and there's pneumatics and so forth. But because right at the beginning I thought about this might be something we can use in the future, it made that possible. Whereas if I'd gone for that quick get it done, then we may never have developed that instrument.
Right.
So, I mean, we're doing general introduction to programming, but we're beginning a program. Mm-hmm. And so we could think about this and go, oh, well, this is just a thing that we're doing for a bit of fun, and we're never going to try and release it, and it's not going to become a major big thing or whatever. We just want to have this idea. Mm-hmm. But I think that those things always end in tears.
Yeah.
And spaghetti code. So this is why even though I said at my little outro on this readout on the last bit of the last video, said, look, next time we'll do some coding.
It was a lie.
Well, this is really this is.
It's like analog coding.
This is coding. Mm. It's just we haven't got a compiler. Well, we're not going to get a compiler because I started to talk a bit before. You said RAM is memory, and I didn't change topic and everything like that. But I've forgotten what I was going to say. Anyway,
something about a compiler.
Yeah, no, that's right. The interpreter and compile. So you have the distinction there is if you use C++ and a number of other languages, you write the code and then you build the code and it turns into a binary file which has got the instructions that the computer can read in binary. But then when you compile it, it's compiled to run on Windows or it's compiled to run on Linux. Right. And so, and trying to make something that's cross-compilable, you have to put in a whole lot of pre-compiler instructions. So you put in these in C++, you put in these statements, hash this and hash that, and hash define. And if you hash define and it's Windows, then you put down if def if hash define. I can't remember, it's a long time since I've written C++. But there's a set of instructions. And when you write the program, you go, if it's defined as Windows, then this is the code. And it's pre-compiler. So it comes in and it reads that and goes, okay. And so you set it up at the top and say, this one I want to build now for Windows. This one I want to build for Linux. This one I want to build for Mac. And so you've got all these instructions. You have to write them all in. And then you do a build for Windows, and then you do a build. And then you go to the websites where you download a lot of software, and they've got a set of links. And it's got Windows 64, Windows 32, it's got, and you have to pick the installer that you want, you download. And then that installs the binary, and in Windows it creates an executable. And so the .exe files, they're a compiled piece of code. And they run faster, like I said, and so forth. But if it's interpreted, it'd be perfect, it'd be wonderful if it worked that easy. Java's got a nightmare of, if you just got the wrong library, it breaks. Tiniest little things. And what happens is Java put out a new release, and they say, oh, we need to fix this security thing. And so we tighten up this thing, and now it won't do this. And millions of small apps over the world break quietly in the background, and techs go, and then have to go out there and, can we get this to run on the new one? Do we have to run the old one? Blah, blah, blah.
Right. It's kind of like, actually, so video games often have modding communities, which are just like people who come in and, tinker with the code and add their own things to it. But anytime there is a new update to the game, like the Sims community is basically run on modders right now because the game itself is a bit garbage, but the mods are really good. But every time the Sims comes in with a new update, you have to wait for the people who wrote the mods to go and update the things and check whether there still works. If it doesn't work, they have to fix it. It's like a whole thing.
But I've found Python so far, and I haven't got a lot of experience pushing it around operating systems, but there was some code in Python 2.7. I'm overseeing building and installing a sun tracker on our new lab. And
I've seen the dot of light.
Yeah, we've got a beam of light that's sitting there's a sun tracker that follows the sun and puts a beam of light down into an instrument. And what happens is the sun puts out infrared light, that light travels through the atmosphere, all the way down to our mirror, through the atmosphere. We know what the spectrum of that light is at the top of the atmosphere. And then it gets absorbed by different gases as it comes down through the atmosphere. It hits our mirror, goes down to our spectrometer. And then that spectrometer looks at that absorption, and we get a total measurement of gas like CO2. We're part of a global network. We collaborate with NASA. And they use our data. We look after a station up in Darwin and the one here, but also about 25 other stations around there, about $1 million to set up a station. But it gives you a total measurement of CO2, carbon dioxide in the atmosphere. And so satellites come over, NASA's and European Space Agency and the Japanese. They've got these satellites that are environmental satellites, and we will get notified to say that there's a GOSAT, for example. There'll be a GOSAT day, and the GOSAT satellite's going to be going over the top of us, so they target our station as they fly over, and they measure the atmosphere. They're using reflected light. It goes through and bounces out, and the satellite catches the reflected. So they target our station as they fly over, and then we measure the same air. So we get told, you've got to use this detector, you've got to use this beam splitter, etc., to get this measurement. So they specify, and there's depending on which satellite, which ones you use. And we measure the same air. And then that data goes across to NASA and ESA and others, and they use it to make sure to validate, not calibrate, but validate. I got into trouble for calling it calibration. But they use it to verify that the satellites are still measuring correctly. Mm-hmm. So we can make sure our instruments are really, really precisely and accurately calibrated. And so they will be able to see if the satellite measurement drifts, because they can't really get up there and run them, run calibrations. So I've totally lost why I was talking about that. Anyway, that's what we do.
That's what happens.
Oh, that's right. Well, I'm setting up the sun tracker.
Yes, sorry.
I'm setting up the sun tracker and trying to get this beam of light to sit really stable, because we need to look right at the centre of the sun. We can't look to the left of the centre of the sun or the right of the centre. We can look a little high or low, but the sun is rotating on its axis. And so one half of the sun is coming towards us and the other half is going away. So it'll shift red or blue depending on whether it's coming toward or away. So then it shifts all our spectrum lines. So we need to be pointed
right in the middle,
really, really carefully at the centre of the sun. And so I'm actually at the point of I've got the beam, so at a first level, dead reckoning, it's holding it. And now we've got this extra layer of correction that's happening all the time. Every second it gets analysed and corrected. But I got code that was in Python, and it was written, and they were running it on on Python, Linux. And I got it running in Linux, but I didn't want to run two computers because the software that runs the big spectrometer only runs on Windows. Mm-hmm. So I had to do the two, and so now I ran a virtual machine, Linux, onto the main one, but I didn't like having to maintain it. So then I took the Python code and dropped it into Windows and said, let's see if I get this to run. And it took a little bit of work, but I've now got it running in Windows, so I don't have to run my virtual machine.
Gotcha.
So now I've just got and now I have to make my Python software collaborate with the Sun Tracker software. But all of this goes back to Python is an interpreted language. And so it meant that I just had to get the right libraries installed on Windows, and then it ran out of the box.
Okay.
So compiled has got advantages, and interpreted has advantages.
Right.
We're going to be running in Python, which is interpreted.
Okay.
I'm kind of crossing off a few things that when I watched back the videos, I went, oh yeah, okay. So, so now back to algorithms.
All right.
But all of these things, so your description of an algorithm, before you write your program, you should know what you want the program to do. Mm-hmm. Now, when you first start writing code, you've never done it before, most people, myself included, you get a mate of mine, Ken Percival, said, oh, you'd love programming. And I went, huh? And so he wrote something. But you write these things and you just think, oh, now I want to print this to the screen. Now I want to do this. And you don't even think about the program before you start. You just start writing lines of code. And then you get to a point where you go, oh, now I want to do this. Oh, I've realised I can cut and paste that bit because I want to do the same thing again, but it's nearly the same. And then you end up with this thing and it just goes on and on and on and on. And then you try to understand it, and then you decide you're going to do something else. And no, that doesn't work at all. And then you end up with, I ended up with this major recursive loop on a program I've been writing. I didn't know what recursion was. And all I knew is it came up with a Stack Overflow error every time I run it after about 3 minutes or something.
Right.
And so I'm trying to head all of that off for you.
Thank you, I appreciate it.
That's pain that most people go through.
Right.
Now, you will, to some extent, but if we get in right, if we start at the right place...
Hopefully I can avoid the worst of it.
We can... So, that means that you have to be really patient before you actually pull up and start typing. Mm. So the algorithm is what you described. We need to have a sense of what we want the computer to do before we start writing it, because then we can look, because every problem has a million solutions. Yeah. Some of them are really ugly and are going to fall apart, but get you a little way. And some will stand the test of time and will still be being used. I mean, my code's still there and it's 18 years old and still running instruments. So it stood the test of time. Right. So what I'm thinking, and I don't know how much this is going to get edited out, but it might not be, because I think people seem to be engaging with...
They find it interesting.
So it might stay in. Anyway, we need now to work out our algorithm. Mm-hmm. So... I said to you off camera previously that you could do everything you're doing on a computer with marbles and holes, and you could say, well, there's 8, in sets of 8, and you could do the calculations, and you could, it'd just take millions of years to do something that the computer does in half a second, but it could be done, right? In theory. So what we want to do before we start busily writing,
tippity typing, is
let's look at the algorithm, and let's then move to what's called pseudocode. So you can, in pseudocode, you write out in code form, like a description of do this, then do this, and then do this, and if that, do that. And if else, otherwise, do that, and you write it all down, and then that pseudocode is the algorithm, describes the algorithm, and then you go to your particular language and say, in Python, how do I do this? Right. In C++, how do I do this? But you can have a program running exactly the same algorithm in any language, so long as the language is able to do what the pseudocode asks for. Some languages really easily do something and others don't, and some have got things you can and can't. But basically, At the algorithm level, at the pseudocode level, that is independent of the language.
Right.
So how do we work that out? Well, I suggest that we play your game. And I play the role of the computer, and you play the role of the game player.
Oh, okay. All right.
Okay. Now, the rules of this game are, I know nothing about what you want to do.
Because you're the computer.
I'm the computer.
Oh, okay, great.
I know nothing about what you do, and unless you tell me very specifically, I'm not going to guess. I'm not going to learn.
Right.
I'm not.
You will only do what I ask you to do.
And that's the problem with computers, is they do exactly what you tell them to.
They're like genies.
And you go, oh no! You know what I meant!
On the monkey paw, no! Yeah.
You know what I meant!
Okay.
And the computer goes, alright? So if before you can write this, you need to understand it. So I can be the computer.
Right, okay.
So we've got these things. And but then there's a way to play the game, and these are part of playing the game.
Okay.
And we will write our algorithm out as we're going. So, I am the computer. And I am waiting to do your bidding.
Yeah.
I've got registers sitting there waiting to perform operations. And I've got memory locations that you can load things into and retrieve them.
Okay.
But I know nothing.
Okay. Ooh, okay.
Okay?
All right.
So this is, honestly, I think, if I've done this a lot of times with complicated programs. Not maybe in this format, but basically this.
Right.
So, what do you want me to do? We're about to start playing the game.
Okay.
What do we need?
Okay. Okay.